In this video, we're going to focus on solving differential equations by means of separating variables. So let's start with this example problem. dy dx is equal to x squared divided by y squared. Now, in this problem, what we need to do is separate the variables. On one side, we only want to have y variables, and on the other side of the equation, we only want to have x variables. So since we have a fraction separated by an equal sign, let's cross multiply. dy times y squared is simply y squared dy. And on the other side, it's going to be x squared dx. Now that we've separated the variables, we can integrate both sides of the function. The antiderivative of y squared is y cubed divided by 3. The antiderivative of x squared is x cubed divided by 3. And on one side of the equation, we need to add a constant c. So now let's get y by itself. So let's multiply both sides of the equation by 3. So it's going to be y cubed is equal to x cubed plus 3c. Now 3c is a constant, so we can just write c for the total sum of all constants. So you can rewrite this as y cubed is equal to x cubed plus c. And so this is the answer. Now if you want to, you can take the cube root of both sides and simplify it further. So y is equal to the cube root of x cubed plus c. So this is the general solution. Now let's say if we want to find a particular solution. If we're given an initial condition, let's say y of 1 is equal to 2. If you're given a point, an x and y value, you need to solve for c. Y is equal to 2 and x is equal to 1. So in order to get c by itself, we need to raise both sides to the third power. 2 to the third is equal to 8. The cube of a cube root cancels, and it's just going to be 1 plus c. So we could see that 7 is equal to c. So the particular solution is y is equal to the cube root of x cubed plus 7. So this is the general solution, and this is the particular solution given the initial condition. Let's work on another example. Let's say that y prime is equal to x times y. Go ahead and pause the video and see if you can get this answer. And let's say that the initial condition is y0 is equal to 5. You can also view this as the point 0, 5. X is 0 and y is 5. So let's begin. Y prime is the same as dy over dx. So we need to separate x and y. And let's begin by multiplying both sides by dx. So therefore, dy is equal to xy dx. Now let's divide both sides by y. So on the left, what we have now is 1 over y dy, and this is equal to x dx. So now let's find the antiderivative of both sides. The antiderivative of 1 over y is the natural log of y, or I'm just going to write it as ln y. And the antiderivative of x is x squared over 2 plus c. So now what do you think we should do at this point? At this point, what we can do is place both sides of the function on the exponents of e. If ln y is equal to x squared over 2 plus c, then e to the ln y is equal to e 1/2 x squared plus c. Since the bases are the same, then the exponents are equal to each other. Now e to the ln y, notice that natural log always have a base e. These will cancel, and so you just get y on the left side. And that's equal to e raised to the 1/2 x squared plus c. Now how can we separate x squared and c? Now, it's important to understand that x squared times x cubed is equal to x2 plus 3, which is x to the 5th power. Whenever you multiply by common bases, you need to add exponents. So therefore, the reverse is true. Let's say if we have x raised to the 4 plus 7, we could separate 4 and 7 by rewriting it as x to the 4th times x to the 7th, the same way as we did it here. So therefore, we could separate the 1/2 x squared from c by means of multiplication. So this is e 1/2 x squared times e to the c. Now, e raised to the c is a constant, so we could simply replace that with c. Therefore, the general solution is y is equal to c times e raised to the 1/2 x squared. Now, the last thing that we need to do is find the particular solution. So we said that y of 0 is equal to 5. So let's find the value of the constant c. So y is 5 and x is 0. 0 squared is 0 times 1/2, that's 0. So what we have is e raised to the 0 power. Anything raised to the 0 power is equal to 1. So therefore, we could see that c is equal to 5. So the particular solution is 5e raised to the 1/2 x squared. And so that's the answer to this problem. And here is the general solution. Here's another problem for you. Let's say that dy divided by dx is equal to y squared plus 1. And let's say that you're given an initial condition. F of 1 is equal to 0. Or rather, y of 1 is equal to 0. So go ahead and find the general solution and the particular solution to this differential equation. So feel free to pause the video and work on this example. Now let's begin. Let's start by multiplying both sides by dx. So what we now have is dy is equal to y squared plus 1 times dx. So we need to move the y variable to the other side. And the best way to do that, to separate it from dx, is to divide both sides by y squared plus 1. Let's rewrite it as 1 over y squared plus 1 times dy, and that's equal to dx. So now let's find the antiderivative of both sides. So what is the antiderivative of 1 over y squared plus 1? Well, it helps to know that the derivative of the inverse tangent of x is equal to 1 over 1 plus x squared. So this is going to be the antiderivative. The antiderivative of 1 over y squared plus 1 is inverse tangent y. So that's what we're going to have on the left side. On the right side, the antiderivative of dx is simply 1x plus c, or just x plus c. Now what would you do at this point? What we need to do is take the tangent of both sides of the equation. That's how we can separate inverse tangent from y. Tangent and inverse tangent, these two cancel. So on the left side, this is going to be y is equal to tangent x plus c. So this is the general equation. Now we were given an initial point, y of 1 is equal to 0. So let's replace y with 0 and x with 1. And let's solve for c. Tangent of what angle is equal to 1? 0, not 1. Tangent of 0 is equal to 0. Tangent of pi is equal to 0 as well, but let's use this one. So therefore, 1 plus c has to be equal to 0, which means that c is equal to -1. So one of the particular solutions is y is equal to tangent x minus 1. Now granted, I guess you can set 1 plus c equal to pi. You could do that for 2 pi, 3 pi, and it's just going to keep on going. But I just chose one of those answers, and here's one particular solution.